1. Today we will be demonstrating an earthquake model, that is tuned mass damper, which is one of the vibration control techniques. During the ground motion, due to seismic events, the structure tends to vibrate in various directions. Let's say, suppose this structure, when it's during the seismic event, when it vibrates towards this direction, let's say the distance is x1, and when it comes back to its original position, the total time taken is known as time period, and similarly it continues to sway in other direction, and when it comes back to its original position, let's say the distance is x2, it is found that the distance x1 is always greater than x2, and this is due to damping in the structure. And damping basically means the dissipation of energy due to friction in the structures. To counteract these forces due to seismic event, we can design the building by increasing the dimension of the vertical components such as column and wall, which stiffens the structure. Well, this is the last option taken by the architect. So engineers have to sit back and look into some of the unconventional technique, one of which is tune a building like a guitar. Yes, you can tune a building just like your favorite instrument. However, you must be wondering how it is done, right? We have the solution, and that is tuned mass damper, which is also known as harmonic absorber. Now, to give a brief description about our model, we have considered two G+3 frames, and inside this box we have high-speed rotating motor, and when I switch on this plug, it gives motion to the structure, which displaces the structure in lateral direction. Now, just like in a real seismic event, now I will demonstrate you how the structure sways in the lateral direction during the seismic event.
Now I'd like to demonstrate how a tuned mass damper reduces sway in a building during an earthquake in real life scenario. This is a building provided with a tuned mass damper made of concrete, while this is a building without a tuned mass damper. Let's observe how these buildings behave when a lateral force is introduced to them. We can clearly observe that the building provided with the tuned mass damper has a significant reduction in the sway. This is because the tuned mass damper moves out of sync with the building, thereby counteracting the forces and reducing the sway of the building. Now that we have shown how a tuned mass damper works, what exactly is a tuned mass damper? A tuned mass damper is a device with a spring, mass and damper which is attached to a vibrating structure to reduce the dynamic response. There are two main types of tuned mass dampers: horizontal tuned mass dampers and vertical tuned mass dampers. Our model is a horizontal tuned mass damper. Horizontal tuned mass dampers are mainly used in buildings and towers, while vertical tuned mass dampers are usually used in bridges and walkways. Tuned mass dampers mainly works on the action of a damped spring mass system which is attached to a main vibrating body. Basically, the tuned mass system acts out of sync with the vibrating structure, thereby reducing the amplitude of the vibration. This is a graphical representation of a single degree of freedom system provided with a tuned mass damper. M1 here represents the mass of the structure, while M2 represents the mass of the tuned mass damper. For this system to work, we need to take into consideration three main factors, that is the mass ratio, the damping ratio and the frequency ratio. For the tuned mass damper to work, the frequencies of the structure and the tuned mass damper needs to be as close as possible to each other. This graph represents the behavior of a structure with and without tuned mass damper. The green line here represents the amplitude of vibration of a building without tuned mass damper. And after providing TMG, we observe that the amplitude of vibration has significantly reduced, as shown by the dark line here. When do we use tuned mass dampers? Tuned mass dampers can be used in our structures if it is included in the initial concept design of the structures, whereby the horizontal and vertical elements are reduced in their size. However, this is only possible if the horizontal and vertical elements have achieved the strength requirements. It can also be used as retrofits in our existing structures where acceleration and vibration issues have been determined. Some very famous examples of where tuned mass dampers have been used are Taipei Tower, where the tuned mass dampers was used in the building because the building was located near a fault line and it was susceptible to very strong typhoons. Another very famous examples where TMD was used is the Burj Al Arab Hotel, which is a 7-star hotel located in the UAE. The tuned mass damper was used because it was located near the sea and was susceptible to vortex shedding of wind. In conclusion, we have observed that using tuned mass dampers in our structures is highly beneficial during seismic events, but we cannot directly incorporate tuned mass dampers in our structures as we have to take into account many factors. But the two main factors that need to be taken into consideration are the location of the tuned mass damper in the structure and the cost of the structure with and without the tuned mass damper.